Hi everybody, in this video we are going to use trigonometric identities in applications, and we are given this prompt that you see on the screen right now. Given tan theta equals negative 5 root 39 over 39, pause, address that situation. Even without reading further, tangent is negative. So that means my reference triangle and my terminal side of my angle will be in quadrant 2 or 4. Also, by the look of it, this appears to be a ratio that has been rationalized from whose denominator has been rationalized, and that's going to be important in a moment. Continue. Now the way you would read this over here is you say theta is between 3 pi over 2 and 2 pi. So that straight up, no mystery anymore, indicates that the reference angle is, reference triangle is going to be in quadrant 4. Find the exact value of sine theta over 2. So let's get started. If I draw my reference triangle, that is something that we learned to do a while ago. I'm in quadrant 4. So here I have an x-axis. This right here is the y-axis, quadrant 4, right? And my reference angle would be located right there. Now, normally, so I'm just going to switch pen color so I can kind of write over this in a minute, but let's do, okay, I'm going to do like a dark yellow because I don't really want it to show too much. Opposite over adjacent, so I can think of this side as 5 root 39, okay? It's negative because we're going down, right? And then that makes the side up here, the adjacent side, that would make that side 39. Okay. Now, to find the sine half angle, we are going to use a half angle identity. The half angle identity for sine uses cosine of theta. In order to find cosine of theta, we need to find the hypotenuse. In order to find the hypotenuse, we are going to do Pythagorean theorem. It says find the exact value, which implies that this problem should be doable without touching a calculator at all. No rounding. You may have radicals in your answer, but no rounding, no decimals. To do Pythagorean theorem on these numbers right here is going to be annoying, so I have a lovely trick for us, okay? So if I do Pythagorean theorem, you could straight up ignore the negatives because there's a lot of people that keep squaring with negative numbers and getting a negative number. If you don't know that when you're squaring, like if you are squaring negative 5 root 39, that leg squared looks like this, okay? Plus other leg squared looks like this, equals hypotenuse squared. If you don't know that that negative squared is positive, just stop using it. And then just put negatives in place where you need to when you find them for the legs, the opposite or adjacent sides when you're going left or down. You put those in, okay? Because you can't keep messing those up, guys, just saying. Now, that's annoying. I don't know what 39 squared is. I don't know. I don't want to know. It's annoying. So what's the trick, you say? I'm glad you asked. So negative 5 root 39 over 39. I want you to think, what did this ratio look like before it was rationalized? So to unrationalize it, you could probably do it in your head, I believe, at this point, right? Or we can rationalize the numerator, which will put the radical back in the denominator by multiplying again on top and bottom by root 39. If you could just look at it, I feel like you could tell it was negative 5 over root 39 prior to being rationalized. So what I'm going to do is I'm going to redo my sides on my triangle with that being the opposite and that being the adjacent. This is just a scaled down version of those measurements, and what we know about trigonometry is that we reduce down to fractions and the angles stay consistent, right? Like the ratio is the ratio. Now, if I go to put that in, opposite is just negative 5 now, okay? Adjacent is square root of 39. So now, when I go to do my Pythagorean theorem instead, negative 5 squared plus root 39 squared is hypotenuse squared. So how much easier is that, right? Negative 5 squared is 25. Square root of 39 squared is 39. Equals hypotenuse squared. That's 64, which means the hypotenuse is going to be 8 because the hypotenuse, that side of the triangle in this type of problem, is always positive. So there we go. We got 8. Now, let's dive into using the identity. So 2 layers to it. Sine of theta over 2 is, you should know the identity by heart. Just saying, should. 1 minus cosine theta all over 2, all underneath one entire radical. So the radical is over the numerator and the denominator. We have plus minus in front. It is not both. Just one. We have to determine which one, but we'll do that at the end, okay? Don't forget to do that. Whether you want to just always do it at the end, at the beginning, I don't know. You pick, but you got to do it right. So what's going to happen? So I'm going to have, for now, keep it plus minus. Square root of 1 minus. What is cosine of theta? There's theta. Theta over 2, where is that? I don't know. I don't know what theta is. Theta could be this little negative angle. Theta could be this big baby that goes all the way around. Well, probably is because it told us in the question it's between 3 pi over 2 and 2 pi. It doesn't really matter so much, but once you establish what theta is, all we know about half of theta is that it's in the bounds that are half of that. Okay? So that's going to matter. But in the problem, this is still theta. So that means we still use the picture to figure out cosine of theta. To figure out the final answer, which is of sine of half theta, we have to consider half theta. Okay? It all makes sense. So 1 minus cosine is adjacent over hypotenuse. So root 39 over 8 all over 2. Now, I'm not a big fan of the way some people are cleaning this up. You're like your algebra, it's a little babyish, kind of like it's so messy and so many steps. So one thing I think that you should do to clean things up a bit, and by I mean clean up, I mean not just the work, the problem, but the way your work looks and how it is in your head. What would be, looking at all the fractions within this fraction, that's really 1 over 1, 2 over 1, root 39 over 8. Determine what the lowest common denominator would be. In this case, it would be 8. And I'm going to multiply the entire numerator, this whole thing right here, by 8, and the bottom by 8. I'm technically multiplying by 1, totally legal. From there, plus minus square root of, what do we got? Distribute that 8, that's 8. Minus, if you tell me 8 root 39 over 8, start math over from kindergarten. The 8's cross out, we have root 39 over, we have 16. Now, this radical is over both the top and the bottom. I'm going to separate it. Here's the top. I'm going to do a little doop, 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 and there's the bottom. Square root of 16 is a perfect square. That's why I'm doing that, right? Cute. Top is 8 minus root 39. I'm going to put parentheses, even though the numerator it is implied that there's parentheses. Now, is it plus or is it minus? Which one, right? How do we figure it out? Go back to what theta is. Theta is less than 2 pi, but theta is greater than 3 pi over 2. It's between 3 pi over 2 and 2 pi. If that's the case, right, then what is half of theta between? Well, divide everyone by 2. It's between pi, and half of this is 3 pi over 4. So where is theta over 2? Theta over 2, right? This angle will terminate between, what did we just say? 3 pi over 4, which is here, and pi, which is here. So this sine is going to terminate in the second half of quadrant 2, which means my answer should be positive. So I would suggest don't neglect the plus sign. Put the plus sign there so you know you did it, you had intentionality there, and you're not just getting lucky by forgetting to do the sign. Show that you actually know that that's the answer. So this is one way you could write this answer. You could also do a little bit of a pretzel to it where you reduce that and reduce, well, you can't reduce that. So that would give you 2 minus root 39 over 4. I mean, it's the same answer. I just think the one I put in the cloud, a little cuter. Okay? So hope that was helpful. Hope you are able to make sense of that. Watch it again if you have to. Maybe come back to it later and watch it again if you have to. So questions, comments, concerns, put it in, or requests in the comment section. If you enjoyed, happy, and you know it, give it a thumbs up. If you are miserable and hate it, cranky pants, go ahead, thumbs down. I will be putting links in the description box, and I'll probably be setting up thumbnail and playlist for all of this. I'm recording backwards. This is the first one I'm doing, so yeah, I'll figure it out. Stay tuned. Bye.